The vector position of an object of mass 1.4 kilograms that begins its motion in 3D is described by the equation of r, where I, j, k is unit vectors along the x, y, z. So we have to find what will be the speed when the magnitude of net force acting on it reaches the value of 28.1 Newton. So we have to find basically the magnitude of the v. First of all, we have to find velocity, which is dr dt. D minus 8t I vector plus 4t squared j vector plus 2t cubed k vector. So you have to take the derivative with respect to time. So in that case, you will get is minus 8 I vector plus 8t j vector plus 6t squared k vector. Okay, so now we got for the v, but as you can see here, we don't know the time, so somehow we have to find the time. The second step will be finding the acceleration, where dv dt. So if you take the derivative with respect to time from the v, you should get like 8 j vector plus 12 t k vector. Okay, so far we have v and a. Now we know that F is equal ma, where the mass is 1.4 multiplied to the 8j vector plus 12t k vector. Okay, this is becomes then 11.2 j vector plus 16.8 t k vector. Okay, now we know that we have to find the speed when the net force acting on it reaches the value of 28.1. So that means when F net is equal to the 28.1, then that should be equal to the 11.2 j vector plus 16.8 t k vector. Okay, then from here what we can do is we can basically square and from there we can find the time. And if you do calculation, then you should find that the time is equal to the 1.53 seconds. Okay, then what we have to do is that we have to take this time and plug it into velocity. Okay, once you plug the velocity, then your velocity should become minus 8 I vector plus 12.24 j vector plus 14 k vector. And since you have to find the magnitude of the v, you just square and take the square root. So the magnitude should be about 20.3 meter per seconds.